Welcome to this video on first-degree equations. Think of an equation as a balance. The goal is to perform the same operation on both sides to find a solution. Then check your work. Remember, mathematics is the art of thinking. When solving equations, be careful to avoid common mistakes. Always perform operations on both sides, watch for sign errors, and never forget to check your final result. Let's start our hunt for the unknown. Consider the equation. 5 plus a box equals 12. What number needs to be in that box to make the statement true? An equation is simply an equality. For example, x plus 5 equals 12 is an equation that states two expressions have the same value. In this equation, x is the variable, representing an unknown quantity. We find x by isolating it, showing that 7 satisfies the equation. Visualizing an equation as a balance helps us understand how to maintain equality. Both sides must always weigh the same. To maintain balance, apply the same operation to both sides. If you subtract 5 from one side, you must subtract 5 from the other. After solving for x, always check your answer. Substituting 7 back into the original equation confirms that the result is correct. We can translate word problems into equations. 4 more than a number is 19 translates directly to x plus 4 equals 19. Shopping problems are also useful. If 5 pencils cost 250, we can represent this as 5x equals 250. When you encounter parentheses, use the distributive property. 2 times the quantity x plus 3 becomes 2x plus 6. Equations can also include fractions. Here we have x over 2 plus 3 equals 7. By isolating the variable in our fractional equation, we find that x equals 8. For equations like 2 times the quantity x plus 3 equals 14, always distribute first to simplify. Finally, solve for x in 2 steps. Subtract 6 from both sides, then divide by 2 to reach the solution. Let's look at another scenario. If the cost of 3 cinema tickets is 450, we can represent this with the equation 3x equals 450. To solve for x, divide both sides by 3. 450 divided by 3 gives us 150, meaning each ticket costs 150. Here is a simple example. 2x equals 10. Our goal is to isolate x by performing the inverse operation. In the equation 2x equals 10, the number 2 is the coefficient of x. We divide both sides by 2 to find that x equals 5. Let's try another example. X plus 5 equals 12. We subtract 5 from both sides to isolate x, leaving us with x equals 7. Finally, we can verify our solution by checking the equation. 7 plus 5 is indeed 12, confirming our answer is correct.